Before I start doing this, you want to make sure you've already done this. So if you haven't, make sure you go through this yourself. I'm just going to run through it pretty quickly. So I've already typed in the equations. If I hit graph, we look, there's x squared, there's negative x squared. We want to see what's the effect of having that negative on the graph. I'm going to go and I'll turn off those, and I'll graph the next set of equations. Notice how that came up. So this part here that was negative is now positive. The part that was positive was made negative. And the part that was positive here, let's see, was made, it was reflected over. So the positive was made negative, the negative was made positive. So I'll come back and I'll write that after I'll look at all these equations. So basically, what is happening to negative f of x? If we start with f of x and we put a negative in front of the f of x represents y numbers. So what this is all the y numbers are flipped. They're changed. So it reflects the graph about the x-axis. Now let's look at the next one, next set of equations. So this one deals with absolute value. So here's my graph of y equals x squared minus 1, and all you saw was that little piece there. Let me show you just with the absolute value graph. It comes down, bounces off, and hit it. Now it's hard to see on the calculator screen here, but that's really actually a sharp point that it's coming. It's just reflected up. So the whole thing wasn't affected, only that little piece that was going to go below. Let's look at the next graph. So we have this graph, it comes up, it goes over the x-axis, comes down, and then back up. And let's see the effect of having the absolute value. We could see part of it was coming down this time instead of going up. Let's turn off the original one and see about graphing. So remember that original one was coming up, now it's coming down. This was negative, now it's positive. It came up and over, that was normal, and then it was going to go down again, but that had to be reflected up. So whereas the negative f of x was making our y values, changing the sign of them, the absolute value of a positive stays positive. Absolute value of the negative makes it positive, so it takes everything on the bottom below the x-axis, everything below the x-axis, and flips it up. Let's take a look at the next graph. And I've set up another calculator for that. So this time we're going to look at f of x and f of negative x. So there's f of x and there's f of negative x. How do those relate? Look at that y-axis part. Let's turn those off. Now, a lot of people will look at this square root of negative x and they'll say, you can't take the square root of negative x. Sure we can for the proper domain. If x is a negative number, then that will make it positive. So let's take a look at what the graph looks like. Here's square root of x, and there's square root of negative x. So what was in both situations? We had that line cutting through, and then we have this square root of x and square root of negative x. What's the effect of negative x? It's reflecting the graph about the y-axis. Let's look at the next set. The next set said, let's switch x and y. Now I already took the liberty to take this. The only way we're going to put this one in on our calculator, at least right in using function mode, is to solve this equation for y. So if we do move the 1 to the other side and divide by 2, we'll have this piece. So let's take a look. We have y equals 2x plus 1. That was a little harder to see. Let's take a look at the next set of graphs. Turn those ones off because it gets a little too crowded. When we solve this one, x equals y squared, y equals plus or minus the square root of x. So there's y equals x squared. This one's also not quite as easy to see since it's not a square window. We could change and make this zoom 5 for a square window, and it should look more of the same. Yes, there's better. Now what's happening on this? X and Y were switched. These graphs are reflections about the line y equals x. Now let's take a look and write that stuff down. So our first set, we were looking at, let me make sure I have my equations here. We were looking at f of x and then negative f of x. So y equals negative x is a reflection about the x-axis. Or we could say y equals reflects f of x about the x-axis. To the absolute value, y equals absolute value of x, reflects the parts of the graph below the x-axis. So it takes that part, or those parts, and it reflects them about the x-axis. It flips them all up. The next one we looked at was y equals f of negative x. And this is a reflection, or we should say, instead of using the reflection, just say this reflects the graph of f of x about the y-axis. That'd probably be a better way to say this one as well, that this reflects the graph of f of x about the x-axis. And the last one we had y equals f of x is what we started with, and then it was a switching there, it said x equals f of y. And what this does is this reflects the graph of f of x about the line y equals x. All right, let's take a look at the next part. Now, all of that stuff we just dealt with in that exploration was dealing with starting with one equation, and then we transformed it into another one. Now what we're going to do is similar, but it deals with only one equation. So what we're going to be talking about is symmetry for one equation. If a graph is symmetric about the x-axis, then if xy is on the graph here and it's symmetric about the x-axis, then x comma negative y is on the graph. If the graph is symmetric about the y-axis and xy is on the graph and we go across the y-axis, then this time it's the x value that's changing, so negative x comma y is on the graph. Symmetric about the line y equals x, well, it's going to be flipped over here. What's that doing? That is switching the x and y values, so we have y comma x is on the graph. And symmetric about the origin, that is the same thing as saying a 180-degree rotation about the origin, that if I have a point there, it'll come down here, and that point will be negative x comma negative y. So negative x comma negative y is on the graph. Let's try to test for symmetries right now. what we're going to do, the basic process, we're going to plug in this point. Now we're not plugging in a specific point. It has to be a general point, like what we were just working on, and see if it simplifies to the original equation. So when we're testing for the x-axis, what we're going to do is plug in x comma negative y. So negative y equals x squared plus 1. Is this the same thing as the original equation, y equals x squared plus 1? No. So is this graph symmetric about the x-axis? No. Let's plug in negative x comma y. Y equals negative x quantity squared plus 1. We simplify that to x squared plus 1. That is the same as our original function. So this is, yes, it is symmetric about the y-axis. Now when we're going to test about symmetry about y equals x, we're going to plug in y comma x. So in other words, in the x spot of the original one, we'll substitute in y. So we'll have y squared plus 1. And in the y spot, we'll substitute x. Can we solve for this and get y equals x squared plus 1? No. So it's not symmetric about the line y equals x. And the origin, we're going to plug in negative y and negative x. And then we get negative y equals x squared plus 1. And that's also no, that's similar to the x-axis one. Let's take a look at the next. At this point, it's just a bunch of examples doing the same basic thing and looking, can you simplify it to the original thing? So we're going to plug in x and then negative y. So we'll have negative y and then x plus negative y equals 4. Now if it helps, what you could do is multiply this out and just take a look and see what you get. If we multiply this out, we'll get negative xy plus y squared equals 4. So the only thing different is one of the three signs. Well, that's not going to work. So this is no. Let's plug in negative x. So we say y, negative x plus y equals 4. We multiply this out, negative xy plus y squared. That's what we got to that one with that one, and so that's also no. Let's plug in yx. So in this time, where the y spot is, we'll plug in x, and where the x spot is, we'll plug in y. So we get xy, well that looking good, plus x squared. Nope, x squared's not the same as y squared. Let's look at the last one, and we have negative y times negative x plus negative y equals 4. We get xy plus y squared equals 4. Yes, this graph is symmetric about the origin. Now it's possible to have multiple symmetries within the same problem. You can't guarantee just by looking at it. You're going to test them, and so for every problem, you are going to do that same thing. Let me do one last one. I'll do problem number 4. So in this case, I'm just going to put x-axis. Looking above, we're plugging in x comma negative y. So we'll have negative y squared times x plus 3x squared equals 2. That simplifies y squared times x plus 3xy squared equals 2. And yes, that is symmetric about that one. Let's try y-axis. And on that one, we're plugging in negative x comma y. So we'll have y squared times negative x plus 3 times negative x quantity squared equals 2. So we get negative xy squared plus 3x squared equals 2. Is that the same as the original one? Nope. 3. This time we test y equals x, so we're plugging in the line y equals x. We'll plug in y comma x. So we have x squared times y plus 3y squared equals 2. That also is different than the original one. And the last one, the origin, we'll plug in negative x comma negative y. So for any of the problems that are asking about symmetries, using symmetries. What I want you to do is actually show me that you've done all this, and this would be no. And that's it.